Hello all, good evening. Welcome to Unacademy. Is India's largest online platform. Okay. In previous lectures, we have seen how to find out the Fourier series in a theoretical way. Now we will see the short tricks how to find out the Fourier series, and we will see MCQs in this lecture, which is very helpful to solve any question from your GATE exam. Okay. Now, before going to start this, let me introduce myself. Dhanashree Mam. I completed my MSc in Mathematics from Mumbai University and your mobile's Play Store app, and then search Unacademy's learning app. After that, you will install the app and see here manage your goal. जैसे कि हम लोग यहाँ पे अभी GATE and ESE के लिए पढ़ रहे हैं, so you can manage your goal like GATE and ESE. So जो भी आप जिस भी एग्जाम के लिए आप प्रिपेयर करना चाहते हो, आप लोग अपना गोल वहाँ पे मैनेज कर सकते हो. Okay. Now next is plus you can take any subscription plan or either for plus subscription, free courses or special classes, whatever you want, you can take your subscription plan here. See here हर एक प्लान के अलग अलग बेनिफिट्स हैं. प्लस के लिए आपको अलग अलग कोचिंग मिल जाएंगे, स्पेशल सीरीज होंगी, टेस्ट सीरीज होंगी, वहाँ पे फ्री कोर्सेज भी है, स्पेशल क्लासेस में आपको भी 1-to-1 गाइडेंस मिल जाएगा. Then so I will suggest you can take any one subscription plan over here. Now you are after that you will press the get subscription button. And the most important thing I will tell you here, सब्सक्रिप्शन प्लान फॉर गेट एंड ESE. यहाँ पे आप लोग देख रहे हो कि अगर आप if you are going to prepare for the GATE 2022, then I will suggest you must go for the plan for 24 months so that your entire syllabus will be covered and you will be ready for the GATE exam 2022. Okay, so it is up to you, but I will suggest if you are going to prepare for the GATE 2022, then definitely you will take a 24 months plan. And most important thing I will tell you here, I'm going to tell you here that you can use my promo code DSP to get the 10% discount on your any subscription plan. Now see here, you can pay your subscription fees by using any one of this method, either debit card, credit card, EMI, UPI, wallets, net banking, anything you can uh, use here to pay your subscription plan. Now, and the most important thing is unlock the free plan of Unacademy with code DSP. Special class, live test series, quiz, Unacademy combat. Here you can use here. और सबसे बड़ी बात मैं यहाँ पे आपको बताने जा रही हूँ, यहाँ पे हमारा अभी 28 दिसंबर से लाइव क्लासेस चालू है, शुरू हो रहे हैं, जिसमें आपको 1-to-1 गाइडेंस मिल जाएगा. जाने माने कोच है. जस्ट अ मिनट, आई विल चेक. From 28 December here, so you will get one minute. Yes, यहाँ पे मैं आपको बताने जा रही हूँ कि हमारा इवॉल्व फॉर द गेट यहाँ पे इवेंट हो रहा है 2022 से. जैसे कि सिविल के लिए है हमारी बैच ए. So you will get here 1-to-1 guidance which starts from 28 December from 11:15 a.m. So be there with the topmost educators from Unacademy, that is Shobhi Srivastava, Anirudh Singh, Jaspal Singh, Dushan Meena, Rajat Johari, so that you will get a 1-to-1 correspondence for the batch. Civil की batch के लिए है, यहाँ पे batch start हो रही है from 28 December morning 11:15. So be there for that batch. So Now next is evolve for the GATE 2022 and here is for mechanical batch है यहाँ पे mechanical की batch start हो रही है batch A which is also in English and Hindi and again it will be starts from 28th December from 6 p.m. So be there, evolve for this batch and the coach, the educators are here. आदित्य गुप्ता जो आपको दिख रहे हैं बार बार आपको दिख रहे होंगे यहाँ पे YouTube पे. So definitely you will be there from the 28th December from 6 p.m. Okay. Now to unlock any plan of to unlock the free plan of Unacademy, you can use my promo code DSP for the special class, live test series, quiz and Unacademy combat. Okay. Now let's start our actual topic, that is Fourier series. MCQs on Fourier series. You must needed these things. So interval in the interval c to c plus 2 pi, Fourier series f of x is equal to a0 by 2 plus summation n varying from 1 to infinity n cos nx plus summation n varying from 1 to infinity bn sin nx, and Fourier constants a0 is equal to 1 by pi integral c to c plus 2 pi f of x dx, and n is equal to 1 by pi integral from c to c plus 2 pi f of x cos nx dx. Bn is equal to 1 upon pi integral from 0 to pi f of x sin nx dx. Right. So you will get here now next interval. In the interval c to c plus 2l, f of x is equal to a0 plus a0 by 2 plus summation n varying from 1 to infinity n cos n pi x by l plus summation n varying from 1 to infinity bn sin n pi x by l, where a0 is equal to 1 by l integral c to c plus 2l f of x dx, n is equal to 1 by l integral from c to c plus 2l f of x cos n pi x by l dx, and bn is equal to 1 by l integral from 0 to c plus 2l, here c plus c to c plus 2l, not 0. Here integral from c to c plus 2l f of x into sin n pi x by l dx. Okay, here we can write here c to c plus 2l f of x into sin n pi x by dl. Now in the interval minus pi to pi, f of x is equal to, you will get a0 by 2 plus summation n varying from 1 to infinity n cos nx, bn is equal to 0 for the even function. Here for the even function you will get this, and for the odd function a0, Fourier constant a0 is equal to 0 and an is equal to 0, right? And here bn is equal to 2 by pi integral from 0 to pi f of x sin nx dx. Now next, half range sine series. In the interval 0 to pi, f of x is equal to summation n varying from 1 to infinity bn sin nx. Bn is equal to, here bn constant bn is equal to, for the Fourier half range sine series, सिर्फ साइन Fourier constant only bn होगा. So 2 by pi integral from 0 to pi f of x sin nx dx, and in the interval 0 to l, bn is equal to 2 by pi 2 by l integral 0 to l f of x sin n pi x by l dx. And for the half range cosine series, you will get here for the interval 0 to pi, f of x is equal to a0 by 2 plus summation n varying from 1 to infinity n cos nx, and Fourier constant a0 is equal to 2 by pi integral from 0 to pi f of x dx, where n is equal to, here not a0, here n is equal to 2 by pi integral from 0 to pi f of x cos nx dx. And for the interval 0 to l, f of x is equal to a0 by 2 summation n varying from 1 to infinity an cos n pi x by l, and a0 is equal to here 2 by pi, sorry, 2 by L, not pi, in the interval 0 to L. 2 by L integral 0 to L f of x dx, and an is equal to 2 by L integral from 0 to L f of x cos n pi x by L dx. Okay, now let's start. The Fourier series expansion of an even function f of x with the period 2 pi defined in the interval minus pi to pi is given by a0 by 2 plus summation n varying from 1 to infinity n cos nx. Then the value of n is given by 1 upon 2 pi integral from 0 to pi f of x cos nx dx. So b is equal to 1 upon pi integral from 0 to pi f of x cos nx dx. So what will be the correct answer for the interval? The Fourier series expansion of an even function in the period 2 pi defined in the interval minus pi to pi. Then it is an is equal to 2 by pi f of minus pi to pi f of x into cos nx dx. Right? So option C. Okay. Now, here is 0 to 2 pi. See the interval from 0 to 2. There is minus pi to pi, 2 by pi integral from 0 to 2 pi. Integral from 0 to pi. Okay. Now let's. The Fourier series expansion of an even function f of x with period 2l defined in the interval minus l to l. Then the value of the coefficient bn is equal to 0 because it is even function. So at that even function only Fourier constant a0 and an will be there. Okay. Next, the Fourier series expansion of an odd function f of x with period 2l defined in the interval minus l to l. The value of the Fourier coefficient a0 and a0 and an is equal to value of the, see, for the odd function f of x only bn, Fourier constant bn is there. So what will be the value of a0 and an? Here value of a0 and an both are 0, right? 0 each. Okay. Now next, you will see the half-range Fourier series, Fourier cosine series. Here, the half-range Fourier cosine series for the f of x defined in the interval 0 to L is, क्या होगा half-range Fourier series for the interval 0 to L? What will be the correct option? Can anybody tell me here? What will be the correct option? The half-range Fourier cosine series for the interval 0 to L. F of x is a0 by 2. Here a0 by 2 plus summation n varying from 1 to infinity n cos n pi x by L plus summation n varying from 1 to infinity bn sin n pi x by L, right, for the interval 0 to L. Now the half range Fourier sine series, one second, it's a half range Fourier cosine series, not for the interval. So here half range Fourier cosine series is a0 by 2 summation n varying from 1 to infinity n cos n x. Next, a0 by 2, here half range Fourier cosine series in the interval 0 to L, a0 by 2 summation n varying from 1 to infinity n cos n pi x by L. Okay. Next, the half range Fourier sine series for the interval f of x, for the function f of x defined in the interval 0 to L. So in that case only sine bn, summation n varying from 1 to infinity bn sin n pi x by L. Next, in finding the Fourier series for the function f of x with period t is equal to 2l given by the numerical values, that is in harmonic analysis, the first harmonic is given by in the interval t is equal to 0 to or t is equal to 2l. So what will be the first harmonic? a1 cos pi x plus b1 sin pi x. Okay. Next, in harmonic analysis, the value of f of x with period t is equal to 2l, the harmonic amplitude of first harmonic a1 cos pi x by l plus b1 sin pi x by l is given by here you will get square root of a1 square plus b1 square. The Fourier series expansion of the function f of x is equal to x minus x square defined in the interval 0 to 2, where f of x plus 2 is equal to f of x is given by, you will get it the 0 to 2 f of x is equal to this a0 by 2. Then the Fourier coefficient a0 is, so Fourier coefficient a0 will be, how to calculate the Fourier coefficient a0? Here a0 is equal to 1 by L integral from 0 to 2L. So that is here 2. 2L is equal to 2. And what is L? 2L is equal to 2. So L is equal to 1. So here a0 is equal to 1 by 1 integral from 0 to 1. 1 upon 1 integral 0 to 2 f of x. F of x is x minus x square dx. Right? So integral here you will get x square by 2 minus x cube by 3 from 0 to 2. So 2 square is 4, 4 by 2 it means 2, minus 2 cube is 8, 8 by 3. So 6 minus 8 by 3, that is minus 2 by 3. So here is minus 2 by 3. Right? Next, the Fourier series expansion of the function f of x is equal to x minus x square defined in the interval 0 to 2, where f of x plus 2 is equal to f of x for all x is given by a0 by 2 plus summation n varying from 1 to infinity n cos nx. Then the Fourier coefficient an is given by, so what will be the Fourier coefficient an here? So you can calculate here an is equal to 1 by L. So 1 by 1 integral from 0 to 2 x minus x square into cos n pi x dx. Right? Here cos n pi x by L dx. Actually here cos n pi x by L dx, but here n is equal to 1. Right? So you will get here value of n is equal to 1, L is equal to 1. So we can directly write down here cos n pi x by L. Now, so 1 by 1, so just integrate it. So you will get by using partial fraction, by pi parts, integral from 0 to 2. So retain the first into integral of second, that is sin n pi x by n pi. Here sin n pi x by n pi minus integration of derivative of first 1 minus 2x into integral of second, that is sin n pi x by n pi. Okay, so what I will do, I will do in the same place, minus integration of this. So integration of this is again, so n is equal to x minus x square into sin n pi x by n pi minus, here again retain the first into integral of second, so minus cos n pi x by n square pi square minus integration of derivative of first, that is minus 2 into integral of second, that is minus cos n pi x by n pi. Right? So again here he will get here minus sign is as it is, and integral of again cos n pi x, this minus and this minus becomes plus, and integral of cos n pi x is sin n pi x upon n square pi square. So you will get the final answer minus 2 sin n pi x minus 2 sin n pi x by n square pi square. Now put the value from here 0 to 2. Okay, so put here 2 minus 2 square, that is 4, but sin 2 n pi is equal to 0. So ultimately this value is 0. Minus here 1 minus 2x minus n is there, 1 minus 2x, so minus 3. This minus 3 and this plus 3, so it will becomes minus 3, right? Minus 3 and cos of this, cos of 2n pi. So cos of 2n pi you will get. Now this minus and this minus becomes plus. So cos of 2n pi is equal to minus 3 upon, here you will get n square pi square, right? Plus 0. Here minus minus, this becomes plus. So plus 0, sine 2n pi is equal to 0. So this will become 0, right? Here this will become 0 plus. So ultimately this will 1 into minus cos 0, this sine 0 0 minus cos 0 is 1. So this will becomes plus 1 by minus 1 by, here is minus 1 by n square, right? So minus 1 by n square. So you will get here minus 1 by n square pi square, and again it is 0. So here minus 1 upon n square pi square. So this minus and this minus becomes plus. So minus 4n square pi square. Okay. Next, the Fourier series expansion of the function f of x. If f of x is equal to x, here f of x is equal to x, defined in the interval 0 to 2 pi for all x, where f of x plus 2 pi is equal to f of x. So for all x is given by, then the Fourier coefficient is 0. Very simple. Fourier coefficient is 0. Here interval 0 to 2 pi. So interval 0 to 2 pi, it means your a0 is equal to 1 by pi, integral from 0 to 2 pi x dx. X square by 2 is 1 by pi from 0 to 2 pi. So 4 pi square by 2 pi, 2 pi only. So option C. Okay. Now next. The Fourier series expansion of the function f of x is equal to x defined in the interval. So Fourier coefficient an. So an is equal to what? Here you will get an. Now if it is like, when we will check whether the function is even or odd, if it is defined in the interval minus pi to pi only. Okay. Then only we can check whether the function is even or odd. Here n is equal to, so we have to evaluate is 1 by pi, integral from 0 to 2 pi f of x into cos nx dx. So 1 by pi, f of x is here x, cos nx dx, 1 by pi, retain the first into integral of second, minus integration of derivative of first into integral of second, sin nx upon n, and integration of this again 1 by pi x into sin nx upon n, minus integration of sin nx is minus cos nx upon n into this n, so n square from 0 to 2 pi. So sin n pi is 0, so this will become 0, plus cos 2 pi is equal to 1. So 1 upon n square pi square, minus, right, minus x is equal to 0, and again 1 upon n square, or 1 by pi into bracket, putting by cos 2 pi is equal to 0. So 1 by 0 plus 1 by n square, minus again cos 0, here is 0, and here plus 1 by n square, right? So here 1 by n square becomes 0. So option C. Okay. Next. So the Fourier series expansion of the function f of x is equal to x defined in the interval. So value of the coefficient bn is equal to 1 by pi, integral from 0 to pi f of x into sin nx dx. So calculate 1 by pi, integral from 0 to pi, f of x is x into sin nx dx. Here. So you will get here retain the first 1 upon pi into retain the first integral of second minus integration of derivative of first is 1 into integral of second 1 by pi x into minus cos nx upon n. This minus becomes plus sin nx upon n square from 0 to pi. So we will get 1 by pi, here pi into cos n pi minus cos n pi, here you will get minus, here n is equal to, x is equal to 2 pi, cos 2 n pi is equal to 1, right? So here is minus 2 pi by n plus, here sin n pi is equal, sin 2 n pi is equal to 0 minus cos 0, but here is 0. So we'll get minus 2 pi by pi n. Pi get cancelled out, so only minus 2 by n. Now next, the Fourier series expansion of the function f of x 1 by 2 into pi minus x defined in the interval is given by f of x is equal, here a0 by 2 plus summation n varying from 1 to infinity n cos nx, then a0 is equal to same way. Here is interval 1 to 2 pi, so 1 by pi integral from 0 to 2 pi 1 by 2 into pi minus x dx, so 1 upon 2 pi x minus x square by 2 from 0 to 2 pi. Here we will get 1 by 2 pi, here x is equal to 2 pi, so 2 pi square minus 2 to get cancel out, so 2 pi square only, 4 pi square, but 4 pi square by 2 it means 2 pi square, 2 pi square minus 2 pi square is equal to 0. The value of a0 is 0. Okay, minus 0 is 0. In the same way you can calculate an, so you will get the value of an is equal to here coefficients pi by 1 by 2 pi minus x, and then the value of an is equal to pi. Okay, the value Fourier series f of x is equal to, then the value of bn is equal to 1 by n. Now next, the Fourier coefficient, Fourier expansion of the function f of x defined in the interval 0 to 2 pi, then the value of the coefficient is value of the a0 by 2 cos nx summation n varying from 1 to infinity bn nx, then Fourier coefficient an is equal a0 not an. So Fourier coefficient an is equal to 1 by n, right? And Fourier coefficient a0 is equal to, here you can calculate a0 if you want, then integral 0 to 2 pi, so a0 is equal to 1 by pi integral from 0 to 2 pi minus x by 2 bracket square dx, right? Pi minus x bracket square dx, so you will get here 1 by pi, so 1 by pi into you will get here pi by 2 pi square minus 2 pi x square upon 4, it from 0 to 2 pi 2 square is 1 by 4. One second, one second. Easily also we can calculate 1 by 2 square is 4 pi. Integral from 0 to 2 pi. So pi minus x bracket raised to 2 dx. So 1 by 4 pi integral of pi minus x. So here pi minus x bracket raised to 3 upon 3. Right? From 0 to 2 pi. So here 1 by 12 and into minus 1. 1 by 12 pi into bracket pi minus 2 pi. Pi minus 2 pi is minus pi. Minus pi cube is pi cube and minus pi cube, and this minus 1 plus minus 0. X is equal to 0. So you will get pi cube. Minus 3. So from 0 to 2 pi minus 2 pi pi minus 2 pi minus pi cube. Minus pi cube and this minus. So you will get plus pi cube minus x is equal to 0. So pi cube minus pi cube. So it will gives you 0. So somewhere we are wrong. And answer is pi square by 6. तो फिर से देखो a0 by 2 a0 ही निकालना है ना हमें. Okay, a0 is 1 upon pi integral 0 to 2 pi f of x dx. So integration of pi minus x dx. So pi minus x. So here is first of all 1 by 4 pi is outside. So integral from 0 to 2 pi pi minus x bracket raised to 2. So, and here 1 by 4 pi into bracket pi minus x bracket raised to 3 upon 3 minus 1. Pi minus x bracket raised to 3 upon minus 3 to derivative of pi minus x, that is minus 3, from 0 to 2 pi. So 1 by 4 pi that 1 by 4 pi into pi square 2 cube. That is very important. 2 cube we forgot. So pi minus pi 2 pi. So that is minus pi cube upon minus 3 minus, here is x is equal to 0. So pi cube upon 3. I think answer is 0. So here 0. A0 is value of A0 is equal to 0. The option is wrong. No. The Fourier series expansion of the function f of x defined in the interval. Exactly similar way we can calculate f of x here. An. Also similarly we can calculate here bn. So bn is equal to, here f of x is equal to e raised to x. So in the interval 0 to 2l minus pi to pi. So in the interval minus pi to pi the function e raised to x is neither even nor odd. Right? So we can calculate here a0 is equal to 1 by pi integral from minus pi to pi e raised to x dx. So here is e raised to x 1 upon pi e raised to x from minus pi to pi. 1 by pi e raised to pi minus e raised to minus pi. Right? This is your function 1 by pi e raised to pi minus e raised to minus pi, option C. Now next, the Fourier series expansion of the function f of x is equal to e raised to x defined in the interval, exactly same function. So defined in the interval is minus pi to pi, where f of x plus 2 pi is equal to f of x for all x is given by a0 by 2 plus summation n varying from 1 to infinity n cos n x plus bn sin n x. Then Fourier coefficient an is equal to. So what will be the coefficient of an? Here you will get coefficient of an is equal to 1 upon pi integral from minus pi to pi e raised to x into cos n x dx. E raised to x into cos n x dx. So you will get 1 by pi integral from minus pi to pi. So you will get here e raised to x into cos bx plus c. So e raised to x upon a square plus b square into a sin a cos bx. So a is 1 cos bx plus b sin bx from minus pi to pi. So put here minus pi to pi e raised to x upon 1 plus n square. So e raised to pi upon 1 plus n square into bracket. Here you will get e raised to pi cos n pi. Right? E raised 1 upon 1 plus n square is outside. E raised to pi cos n pi plus sin n pi is 0. So we will get cos n pi upon a pi into bracket 1 plus n square into e raised to pi minus e raised to minus pi. So option D. Next. Then the Fourier constant A0 is already here done. Then the Fourier constant A0 is f of x is equal to x cos x. A0 is equal to in the interval minus pi to pi. So in the interval minus pi to pi, so you will get A0 is equal, then the Fourier coefficient A0 is given by the Fourier coefficient A0 is equal to, you can calculate here A0 is equal to 2 by pi from 0 to pi, right? By pi from 0 to pi f of x, that is x cos x dx. So you will get here x cos x dx is equal to 3 10 the first into integral of second minus integration of derivative of first into integral of second dx. So x into 2 by pi sin n x upon n minus plus cos n x upon n square from 0 to pi. Now pi into sin n pi is 0. Cos n pi, here cos n pi is equal to minus 1 raised to n upon n square. Right here minus 1 raised to n upon n square. So options are wrong here. So minus 1 upon 1 n square and here we will get 2 by pi minus 1 raised to n upon n square minus cos 0. So minus 1 upon n square. So this is the correct option. These options are wrong. Next. 1 minus root of then the A0. A0 is equal to here 1 by in the interval 0 to 2 pi. in the interval 0 to 2 pi, a0 is equal to 1 upon pi integral from 0 to 2 pi. F of x is 1 minus cos x dx. So 1 by pi integral from 0 to 2 pi root of 1 minus cos x. So what is the root of 1 minus cos x? Here we can write down root of 2 by 2 dx, right? So 1 by pi root 2 outside root 2 by pi integral from 0 to 2 pi sin x by 2 dx. So root 2 by pi sin x by 2 integration is minus x by 2 into 1 by 2, right? So here 1 by 2, it means 1 by root 2 pi. 1 by root 2 pi to minus cos x by 2 from 0 to 2 pi. So 0 to 2 pi, 2 to get cancelled out, cos pi is minus 1 and minus 1 and this minus sign, so plus 1. 1 by root 2 pi 1 minus cos 0 is 1. This minus plus 1. 2 by root 2 pi, right? 2 by root 2 pi. So here we can write 2 upon root 2 pi. So here root 2 by pi. Correct option is this. The Fourier series sine expansion of the function f of x is equal to here x sine x defined in the interval 0 to 2 pi is given by, then the Fourier coefficient a0. So a0 is equal to, you will get here 1 by pi integral from 0 to 2 pi f of x. Here f of x is x into sine x. 1 by pi, written the first, integral of second, minus integration of derivative of first 1 into integral of second, that is minus cos nx upon n dx. So 1 by pi minus x cos nx upon n minus this plus and sin nx upon n from 0 to 2 pi, right? So put x is equal to 2 pi cos 2n pi by n. So cos 2n pi by n, cos 2n pi is 1. So 1 by pi, there is minus 2 pi by n, sin 2n pi is 0, plus 0 minus cos 0 is 1, but here is 0, so 0 plus 0. Pi get cancelled out, so here is minus 2 by n. So correct option is minus 2 by n. Next, the Fourier series expansion of the function defined in the interval with period 2 pi, with period 2, then given, then the Fourier coefficient a0 is. The interval minus 1 to 1. So here 1 by L minus 1 to 1 x minus x square dx. X square by 2 minus x cube by 3 from minus 1 to 1, right? So my 1 square, that is 1 by 2 minus 1 by 3 minus 1 by 2 minus 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 plus 1 by 3. T minus 2 by 1 by 6 minus 5 by 6 minus 1 by 6 minus 5 by 6. So minus 4 by 6 minus 2 by 3. Next. The constant term a0, Fourier series expansion of the function f of x in the interval 0 to 4. Here 0 to 4, it means L is equal to 4. Right? So 1 by L. 2L is equal to 4. So L is equal to 2. Yeah. L is equal to 4. So here L is equal to 2L is equal to 4. So L is equal to 2. So A0 is equal to 1 by L. It means 1 by 2 integral from 0 to 4. 2x minus x square. Here is 2x minus x square dx. So 1 by 2 integral from 0 to 4. Integration of 2x is integration of 2x is 2x square by 2 minus x cube by 3 from 0 to 4. Need to get cancel out. So 1 by 2 into bracket we'll get here 1 by 2 into bracket 1 2 4 square is 16 minus 4 cube 64 by 3. Okay, minus 0 is 0. 1 by 2 48 minus 64 by 3. So you will get here 8 minus there is 6 16 minus 16 by 6. So minus 8 by 3. Next. The constant full term a0 Fourier series expansion of the minus 1 to 1 is given by here minus 1 to 1 minus x square. So the a0 is equal to 1 by L. 2L is equal to 2. So L is equal to 1. So 1 by 1 integral from 0 to 2L f of x is 1 minus x square dx. So a0 is equal to 1 into integral from 0 to 2 1 minus x square dx. So 1 minus x square dx x minus x cube by 3 from 0 to 2. 2 minus 2 cube is 8 by 3. So 6 minus it. So minus 2 by 3. Right. So correct option is minus 2 by 3. Next. The constant term a0 Fourier series expansion of the function f of x is equal to 1 minus x square. Okay. This is minus 2 by 3. Question is repeated. Fourier coefficient a0 in the Fourier series expansion of the function f of x is equal to k. Okay. Here f of x is equal to k minus L to L is given by. Here minus L to L. So a0 is equal to 2 by L. But here L is equal to L. Integral from 0 to L. F of x dx. 2L 0 to L k dx. So 2 by L. Here you will 2k is outside. Here 1 dx. So x from 0 to L. So 2k by L. Here L minus 0. So L get cancelled out. So value is 2k. Next. Fourier coefficient a0 in the Fourier Fourier series expansion of the function f of x is equal to a, then here pi to pi, minus pi to pi, not pi to pi. Here minus pi to pi. So a0 is equal to 2 by pi integral from 0 to pi f of x dx is equal to 2 by pi integral from 0 to pi a dx. So again 2a by pi x d 0 to pi. So pi pi cancel out 2a. Fourier coefficient n in the Fourier series expansion of the function f of x n is equal to, you will get 1 2 by pi, right? There is 2 by pi integral from 0 to pi f of x is a into cos nx dx. So 2a by pi integral from 0 to pi a cos nx is sin nx upon n from 0 to pi. So 2a by pi sin n pi 0 minus sin 0 0. So answer is 0. F of x is equal to n minus pi to pi. Then it is given by, now if you check the minus and pi, then the Fourier coefficient b1, here coefficient b1, here n, you will get here n, bn, then bn is equal to, here bn minus pi to pi. Now for the odd function f of x is equal to x, f of minus x is equal to minus x, so minus f of x. Here is odd function. For the odd function, so value of the bn is equal to 2 by pi integral from 0 to pi f of x into cos nx. So you will get, ultimately the value is exactly similar way. The Fourier coefficient a0 f of x is equal to cos x in the interval minus pi to pi cos x, then a0 you have to calculate, it is a even function, right? Minus pi to pi is the even function. So if even function, so you will get a1 is equal to 2 by pi integral from 0 to pi f of x to cos x. So you will get here a 2 by pi cos square x dx. Now cos square x dx, it means 2 by pi 1 plus cos 2x by 2 from 0 to pi dx. So 2 by pi, 1 by 2 outside. So x plus sin 2x upon 2 again. 2 get cancel out, 1 by pi. Pi plus, here 1 by pi into bracket pi plus sin 2 pi 0 and sin 0 0. So only 1. 3 is equal. Fourier coefficient n in the half range cosine series. Here half range cosine series. Expansion of the function f of x is equal to x. So automatically you can see here f of x is equal to x is an odd function, and whenever x given function f of x is odd in the interval 0 to pi, okay, in the interval 0 to pi, then you have to calculate the value of an here, right? So if it is interval minus pi to pi, then directly you can calculate the then directly we can write a0 is equal to 0, but here it is the interval 0 to pi, so we can't write directly. So an is equal to 2 by pi integral from 0 to pi x cos nx dx, right? So 2 by pi, written the first, integral of second minus integration of derivative of first into integral of second, that is sin nx upon n, and again integration of this is minus cos nx upon n into n square. So minus minus plus cos nx upon n square. Okay, from 0 to pi. So sin n pi is 0. So 2 by pi into bracket here is 0 plus cos n pi is equal to, you will get here cos n pi is minus 1 raised to n by n square, and minus 0 minus, here you will get x is equal to 0. So this will become 0. Cos 0 is 1 minus 1 upon n square. So the value of this is 2 by pi n square minus 1 raised to n, or cos n pi minus 1. Right? This is also correct. Minus 1 raised to n by n square on n square. So this is option A. Okay. Next. Fourier coefficient A1 in the half range cosine series 0 to 2 pi. So here not A1, actually here is AN. Printing mistake, AN. Fourier coefficient AN. Here AN is equal to 2 by pi integral from 0 to pi f of x cos nx dx. So 2 by pi integral from f of x. So here 0 to pi f of x is sin x into cos nx, right, dx. So you will get here sin nx f of x is sin nx, not sin nx. So 2 by pi into, if I adjust 2 here, 2 into 2, right? So you will get integral from 0 to pi to sin nx cos nx is, you will get sin 2nx upon 2 dx. 2 to cancel out, 1 by pi. So integral of this, just a minute, check it here, question is wrong. Sin nx in the interval sin x in the interval minus pi to pi. Then the Fourier coefficient an is equal to, so sin x is odd function. So whenever there is odd function, then Fourier constant a0 and an are 0. Okay. Then Fourier coefficient a0 in the half range cosine series. Half range cosine series expansion of the function f of x is equal to sin x in the interval 0 to pi. Half range cosine series. So half range cosine series a0 is equal to, you will get here 2 by pi integral from 0 to pi. Now you can check the half range cosine series in that interval. 2 by pi integral from 0 to pi. Here f of x into sin nx. So you will get here sin square x, right? half range sine nx, half range cosine series of the function. Okay. Integral from 0 to pi sin x into cos nx dx, right? So cos nx dx, 2 sin nx cos nx. So here you will get 2 sin nx cos nx. So 2 plus 2 by pi integral from 0 to pi sin x into cos nx dx. 0 to pi sin 2 we can cancel out here. 2 sin nx cos nx dx from 0 to 2 pi sin a. So value of this function from 0 to pi is equal to sin raised to 1 nx cos raised to n nx. So here 4 pi, 4 by pi. Now Fourier coefficient b1, not bn. Here Fourier coefficient b1 in the half range cosine series for the function f of x is equal to cos x. Okay. For the b1 or bn. Fourier coefficient bn in the half range cosine series. So too much wrong questions. Half range cosine series of the function f of x is equal to cos x, 0 less than x less than pi is given by. So in this function half range cosine, so in that bn is equal to 0 because cos x is even function. I think that's it only. How to find out the Fourier coefficients of the given series in the given interval, okay, from 0 to 2. Take one more example. The constant term a0, the constant term a0 in the Fourier series expansion of the function f of x is equal to 2x minus x square in 0 less than or equal to x less than or equal to 3 with period 3 is given by, with period 3 is given by, here with t is equal to, here t is equal to 2l and 2l is equal to 3, so l is equal to 3 by 2. Okay, so a0 we can get here 1 by l, but l is 3 by 2. Integral from 0 to l, 0 to 2l, 2x minus x square dx. So 2 by 3, 1 by 3, 1 upon 3 by 2, it means 2 by 3. Integral from 0 to 3, हो जाएगा 2x square by 2 minus x cube by 3 from 0 to 2 to get cancel out. So 2 by 3 into bracket 3 square. So what is 3 square? 3 square is 9. 9 minus 3 cube by 3. So again 9, 9 minus 9, 0. So ultimately final answer is 0. Okay. I hope you clearly understood how to calculate the Fourier expansion of the given series. Okay. Now let's one more example we will do. One example. Here f of x is equal to x minus x square in the interval -1 to 1. Then age with period 2L is equal to 2. Here. Now here f of x is equal to x with 0 less than or equal to x less than or equal to pi is equal to 0 when pi less than or equal less than x less than or equal to 2 pi. Defined in the interval 0 less than x less than 2 pi is given by then the value of the constant term a0. Okay, so is here t is equal to 2l with the period given t is equal to 2l is equal to 2 pi, right? Here f of x plus 2 pi is equal to f of x. So here period 2l is equal to 2 pi. So therefore L is equal to pi. So A0 is equal to 1 by pi integral from 0 to 2 pi f of x dx is equal to 1 by pi integral from 0 to pi f of x, so x dx. So 1 by pi x square by 2 from 0 to pi. So pi square by 2 into 1 upon pi. तो ये हो जाएगा pi by 2. Okay, this is your final answer. I hope you clearly understood how to solve the Fourier expansion of the series for the given function f of x in all the intervals. This is a short table. You have to remember to solve any example on this. Okay. Thank you so much. If you are liking my videos, please do like, share and subscribe. And Happy New Year. Okay. So I will pick back in the next year 2021. So up to that, keep study and all the best. Okay. Thank you so much.